Greetings everyone, my name is Bhave. This is my teammate Jaren, and our project is titled Distributed Image Classification Service. Next slide, please. Our project is designed to classify images in real time using a pre-trained deep learning model, and users can upload images through a simple interface, and the system provides the classification results almost instantly. So this service is built to handle fluctuating workloads and which makes it highly scalable and efficient. It's a practical application of cloud-based machine learning with real-world use cases in fields like healthcare and autonomous vehicles. And the project highlights how distributed systems can make complex tasks both accessible and impactful. Next slide, please. So let's talk about the main goals of this project. The primary objective of this project was to create a reliable, scalable system for real-time image classification that can adapt to varying user demands. And we wanted to showcase the potential of distributed cloud-based systems to solve complex problems efficiently. Another goal was to ensure seamless integration between different components while maintaining the fault tolerance and high concurrency of the project. And the project also aimed to explore practical applications of such systems, particularly in industries where speed and accuracy are of high importance. And these include fields like medical imaging and safety technologies. Let's talk about the components of the project next. So the project integrates several powerful software and hardware tools. And let's talk about these software tools. First, we have RabbitMQ, which handles task distribution, ensuring every classification task is managed efficiently. Then we have Amazon S3, which provides reliable cloud storage for uploaded images. We have Redis, which stores classification results and metadata for quick access. And Docker allows the deployment of scalable worker containers for processing. And finally, we have REST API, which serves as the interface for users to upload images and retrieve results. And in the hardware components, we have cloud servers, which run all the software components that we have over here. And we have a local GPU or TPU, which is used for development, for the testing and benchmarking of the models that we've used in the project. Now my teammate Jaren will continue.
So, hi guys, my name is Jaren, and this is the system architecture diagram which shows how the project works. So, the flow description is in such a way that the user first uploads the image, where the user submits an image through the REST API servers, and then the image is stored and a task is created using the RabbitMQ. So, what the REST API does is it saves the image to the S3 storage and sends the classification task to the RabbitMQ. Then the task is distributed using RabbitMQ, and RabbitMQ sends these tasks to the processing cluster, where we have several working worker containers containing those deep learning models which do the classification. And then the image is retrieved after classification and stored inside the Redis. And through the Redis, we can call the results using the REST API, and the user can view the classification results. Now, for the component interaction, which has already been explained, now I'm going to show you a demo of how the project works. So, using Docker, we have containerized the REST API. So we will need to stop the previous running REST API to run the new one. As you can see, the REST API server has started, and now we can run the worker files which we have containerized using the Docker. So for that, we need to stop the previous running worker. And yeah, so as you can see from these logs, our project has been connected to the RabbitMQ, and now the worker is waiting for the task, which the RabbitMQ will provide once we upload the image. Now here, I'll I'll run a curl command which will upload an image which we have put in. I can show you the image. So this is the image we are uploading, which is a person sitting on the bike. And so once we run this command, as you can see, we've got the message that file has been uploaded successfully. And the file URL is also mentioned. And as you can see, it has been uploaded to the Amazon AWS S3, which is a cloud storage. And now, as we see in the worker container, we can see the processing in progress, where the YOLO algorithm, which we have used for classification, is currently working and is some of the files are being downloaded. So as you can see, the worker file has performed the classification task, and from this part of the code, you can see that the classification results have been achieved. And in this log, you can see the classification results have been saved to the Redis. And now, once we run this API call, we can retrieve those results, which are something like this. So as you can see, two things have been classified, the person sitting on the bike and the motorcycle itself with the confidence intervals. And this can be used in several other applications like healthcare, like traffic management systems, and so on. And this is the working of the project. And
So each component of our project was tested individually to ensure the functionality before we integrated all of these components. And we used synthetic data sets to validate the classification accuracy and the queue handling locally. And after deployment, we used performance metrics like system response time and task latency. These were monitored on our cloud servers. And we simulated high traffic and component failures, verified the system's fault tolerance and scalability. Detailed logging was implemented to capture errors and facilitate debugging throughout the project lifecycle.
I'll be explaining the workload that a project is able to handle, and the working system was capable of handling significant workloads due to its distributed architecture. Each component played a critical role in maintaining system efficiency. The use of RabbitMQ ensured that tasks were queued and processed in an orderly manner, allowing the systems to manage high concurrency. Docker's containerization enabled rapid scaling, while Redis provided quick access to classification results and minimizing latency. And now, Bhav, I would conclude.
Yeah, our project demonstrates how modern cloud technologies can build scalable, efficient systems for real-time image processing, and its applications are vast. And these are some of it, but it's not limited to these. We can use it in traffic monitoring, healthcare, autonomous vehicles, and illustrate its versatility and social impact. By leveraging tools like RabbitMQ, Redis, and Docker, the system ensures low latency and high accuracy and adaptability to changing demands. So this project emphasizes the importance of distributed systems in tackling real-world challenges and delivering meaningful, impactful solutions. Thank you.